Hey guys, welcome to Calculus Crush. Today we're going to be doing a logarithmic differentiation problem, y equals x to the power of cosx. So what we want to do is find out what the derivative of y is with respect to x. As you can see, we can't use the power rule in this case because we've got a situation where we have y equals f of x to the power of g of x. If it was to the power of a constant like 2 or 3, something like that, we could just use the power rule. But since we have an actual function up there, we can't use that rule. What we need to do is use the properties of logarithms to rewrite this formula in a better way where we can take the derivative. So if you've got y equals f of x to the power of g of x, and you take the natural log of each side, you can use one of the properties of logarithms where when you have the ln of something to the power of something, you can bring that power down in front. It's just one of the properties of how logs work. So ln of f of x to the power of g of x is actually just g of x times ln f of x. This type of form you can take the derivative. Let's get started. So first let's take the natural log of each side. So we have ln y equals ln x to the power of cosine x. So now we can write that as ln y equals cosine x times ln x. Now we're in a good form, we can take the derivative. So first we need to take the derivative of ln y. Now the derivative of the natural log is 1 over whatever's on the inside times the derivative of the inside. And the derivative of y is just y prime. And now for the right side, we have to use the product rule because we have a function times another function. So the product rule is the derivative of the first times the second plus the first times the derivative of the second. So the derivative of the first, the derivative of cosine x, is negative sine x. And then we times it by the second, which is ln x, plus the first, which is just cosine x, times the derivative of ln x, which is 1 over x, times the derivative of x, which is just 1. So I'm not going to write it. So now the derivative is done, but let's do some simplification. So we've got y prime over y equals negative sine x ln x plus, I'm going to do 1 over x times cosine x. Just put the 1 over x in front. So let's try and do some simplification. There's not really much we can do. I'm going to write this a couple of different ways. Most importantly, we need to move the y up, so we isolate y prime. So y prime is equal to y times, and then maybe since we've got a negative here, I'm going to switch the order. So we've got 1 over x cosine of x minus sine of x ln x. And that is equal to, now what is y? We know what y is. Right up at the beginning, y is x times cosine of x. So we just sub that in there. Y equals x times to the power of cosine x. And we have 1 over x cosine x minus sine x ln x. So now I would say this is pretty much done. But I'm going to take it just maybe one more step to do one possible simplification. So what you could do is notice that let's pull out a 1 over x cosine x from this expression here. So what we get is x to the power of cosine x. And we're taking out an x, and we're taking out a cosine x. We're just taking out basically that first term here. So then this first term just becomes a 1 minus, now we've taken out a 1 over x, but this guy doesn't have that. So it's going to need an x. And we're taking out a cosine, but this guy doesn't have it. So it's going to be a sine x over cosine. And then we have ln x. So this doesn't really look any better. I've probably made it more complicated. If we do one more step here, maybe we can make it look a little bit nice. X to the power of cos x over x, that's the same thing as x to the power of cosine x minus 1, because x on the bottom is a minus 1 power. And then we can have this times cosine of x. And then on the inside, we've got 1 minus, now this is actually x tangent x ln x. And yeah, another way to write it, it's probably not actually simpler, but if you've got a textbook and you've got a problem like this and you see the answer in the back of the book and you know, it looks something like this here and you've got this, well, they are the same thing. You just need to do a little bit more simplification. Okay guys, thanks a lot for watching. Until next time.